This time we're going to discuss the parallel circuit which contains one resistor and inductor. From the given quantities we're supposed to find the following. So, because we have given resistance and X of L, I can find very easy Z total. Because I have just two components, resistor and inductor, I'm going to use the product over the sum. So I have Z total is equal R times X of L over R plus X of L, which is equal R 50 ohms and X of L 30 ohms and angle of 90 degrees. Please notice that inductor, right? But in this case, we have to talk about the inductive reactance or impedance of the inductor has always angle 90 degrees. So I have in the denominator 50 ohms plus 30 ohms and angle of 90 degrees. This is equal 25.72 ohms and angle of 59.03 degrees. This is my Z total. Next, we're supposed to find I total. I'm going to find I total by using Ohm's law, which is voltage source over Z total, where voltage source is going to be peak voltage because I have voltage, right, expressed in terms of the sine equation, okay? So this 50 is my 50 volts peak. This is my amplitude over Z total, which is equal 25.72 ohms and angle of 59.03 degrees. Everything is equal 1.94 amps and angle of negative 59.03 degrees. Okay, so this is I total in my circuit, total current. Next, we're supposed to find the current which goes through the resistor. Please notice that we are dealing with the parallel circuit. When we have parallel circuit, the voltage across each component is the same. So I'm supposed to say that voltage source is equal to VR and is also equal to the voltage across the inductor, which is equal 50 volts. So, in order to find the current which goes through the resistor, you're supposed to simply divide VR over resistance, where VR we said is equal 50 volts over resistance, which is equal 50 ohms. This is equal 1 amp. Next, we're supposed to find the current which goes through the inductor. So I have IL is equal VL over X of L, where VL we said is equal 50 volts over X of L is given 30 ohms and angle of 90 degrees. Remember, X of L goes always with angle of 90 degrees. So this is equal 1.67 amps and angle of negative 90 degrees. Okay, so I found the current which goes through the resistor, current which goes through the inductor. Next, we're supposed to verify if our answers are correct. How we're going to do that? We're going to use Kirchhoff current law, which says that the sum of these two currents supposed to give me I total. If I'm going to get the value the same or close to this one, it will mean that we are doing correct calculations. So I have I total equals IR plus IL, where IR is equal 1 amp plus 1.67 amps and angle of negative 90 degrees. Use the calculator and you're supposed to obtain the value of 1.94 amps, an angle of negative 59.08. Of course, degrees. So look at this value and this one. We can say that they are very close to each other. That's why we can continue, because our calculations up to this point are okay. Next, we're supposed to find total admittance, Y total. Okay, so I have Y total is equal 1 over Z total. So I have 1 over Z total is equal 25.72 ohms and angle of 59.03 degrees. This is equal 38.88 millisiemens and angle of negative 59.03 degrees. Okay, so this is my total admittance. Next, we're supposed to find conductance and inductive susceptance. So we have to simply convert this admittance expressed in polar form to the rectangular form. So convert this complex number to the rectangular form. Okay, so I'm going to get 20 millisiemens minus J 33.33 millisiemens. Okay, where the real part, right, is my conductance and imaginary part is my inductive susceptance. Okay. Next, we're supposed to find the power factor. Formula for power factor says power factor is equal cosine of angle theta, which is equal cosine of the angle which is next to Z total. So I have cosine of 59.03 degrees, which is equal 0.514 lag. I'm supposed to use word lag because the angle next to Z total is positive, okay? But also, you're supposed to keep in mind I have lag because we talk about the RL circuit, right? Current in this circuit, right, is going to lag the voltage source, okay? So if you are going to look at the value of I total, we are going to have angle negative 59.03 degrees. Negative is telling me that I'm behind the voltage source, which has basically the angle of 0 degrees. We have no any angle over here, so there is angle 0 degrees. That's why we have word lag. Current is lagging the voltage source. Next, we're supposed to find the true power. P true is equal 1/2. I'm supposed to use 1/2 because I'm dealing with the peak value, is equal voltage across the resistor raised to the second power over resistance, which is equal 1/2 times VR, we said is equal 50 volts, raised to the second power over the resistance, which is equal 50 ohms. Right? This is equal 25 watts. This is the true power in my circuit. Next, we're supposed to find the reactive power. QL is equal 1/2 voltage across the inductor raised to the second power over X of L. This is equal 1/2 times 50 volts raised to the second power over X of L, which is equal 30 ohms. This is equal 41.67 volt ampere reactive. This is the reactive power in my circuit. Next, we're supposed to find the apparent power. S is equal 1/2 voltage source raised to the second power over Z total, which is equal 1/2, and I have 50 volts raised to the second power over Z total, which is equal 25.72 ohms, and angle of 59.03 degrees. This is equal 48.6 volt amp. This is the apparent power in my circuit. Next, I'm supposed to find the series equivalent circuit. In order to do so, I'm supposed to use the value of Z total. Z total is equal 25.72 ohms and angle of 59.03 degrees. Convert this to the rectangular form. You're supposed to obtain 13.23 ohms plus J 22.05 ohms, where the real part of my answer represents the resistance RS, and imaginary part of my answer represents the inductive reactance X of L S. Now I can draw the circuit. Someone is going to say, what about LS, okay, the inductance in my series circuit? I cannot find the inductance because the frequency is not given. If the frequency is not given, I cannot find the inductance because the formula says X of L is equal omega L, or X of L is equal 2 pi FL. I have no numerical value of the omega, and I do not have frequency. That's why at this moment I'm going to say that we cannot find L. So, but we can draw the diagram. Okay, so this is voltage source. This is my RS, which is equal 13.23 ohms, and this is my X of LS, which is equal 22.05 ohms. And Vs is of course 50 sine omega t volts. So we can say that the problem is solved.